Now, I'm going to be talking about statistics today. If that makes you immediately feel a little bit wary, that's okay. That doesn't make you some kind of crazy conspiracy theorist. It makes you skeptical. And when it comes to numbers, especially now, you should be skeptical. But you should also be able to tell which numbers are reliable and which ones aren't. So today I want to try to give you some tools to be able to do that. But before I do, I just want to clarify which numbers I'm talking about here. I'm not talking about claims like 9 out of 10 women would recommend this anti-aging cream. I think a lot of us have always rolled our eyes at numbers like that. What's different now is that people are questioning statistics like the US unemployment rate is 5%. What makes this claim different is that it doesn't come from a private company, it comes from the government. And actually now, about 4 out of 10 Americans distrust the economic data that gets reported by government. Among supporters of President Trump, it's even higher, it's about 7 out of 10. Now, I don't need to tell anyone here that there are a lot of dividing lines in our society right now. And a lot of them start to make sense once you understand people's relationships with these government numbers. See, on the one hand, there are those who say that these statistics are crucial, that we need them to make sense of society as a whole in order to move beyond emotional anecdotes and measure progress in this objective way. And then there are the others who say that these statistics are elitist, maybe even rigged. They don't make sense and they don't really reflect what's happening in people's everyday lives. Now, it kind of feels like that second group is winning the argument right now. We're living in a world of alternative facts where people don't find statistics this kind of common ground, this starting point for debate. This is a problem. There are actually moves in the US right now to get rid of some government statistics altogether. Right now, there's a bill in Congress about measuring racial inequality. The draft law says that government money should not be used to collect data on racial segregation. This is a total disaster. If we don't have this data, how can we observe discrimination, let alone fix it? In other words, how can a government create fair policies if they can't measure current levels of unfairness? And this isn't just about discrimination, it's everything. Think about how can we legislate on healthcare if we don't have good data on health or poverty? How can we have a public debate about immigration if we can't all at least agree on how many people are entering and leaving the country? Statistics come from the state, that's why they got their name. And the point was to better measure the population in order to better serve it. So we need these government numbers, but we also have to move beyond either blindly accepting or blindly rejecting them. We need to learn the skills to be able to spot bad statistics now. I started to learn some of these when I was working in a statistical department that's part of the United Nations. And our job was to find out how many Iraqis had been forced from their homes as a result of the war and what they needed. It was really important work, but it was also incredibly difficult. Every single day, we were making decisions that affected the accuracy of our numbers. Decisions like which parts of the country we should go to, who we should speak to, which questions we should ask. And I started to feel really disillusioned with our work because we thought we were doing a really good job. But the one group of people who could really tell us were the Iraqis, and they rarely got a chance to find our analysis, let alone question it. So I started to feel really determined that the one way to make numbers more accurate is to have as many people as possible be able to question them. So I became a data journalist, and my job is finding these data sets and kind of sharing them with the public. And anyone can do this. You don't have to be a geek or a nerd. You can ignore those words. They're used by people who are trying to say they're smart while pretending they're humble. Absolutely anyone can do this. So I want to give you guys 3 questions that will help you be able to spot some bad statistics. So question number 1 is, can you see uncertainty? Now, one of the things that's really changed people's relationship with numbers, and in fact, even their trust in the media, has been the use of political polls. Now, I personally have a lot of issues with political polls because I think that the role of journalists is actually to report the facts and not attempt to predict them, especially when those predictions can actually damage democracy by signalling to people, don't bother to vote for that guy, he doesn't have a chance. But anyway, let's set that aside for now and talk about the accuracy of this endeavour. So, based on national elections in the UK, Italy, Israel, and of course the most recent US presidential election, using polls to predict electoral outcomes is about as accurate as using the moon to predict hospital admissions. No, seriously, I used actual data from an academic study to draw this. There are a lot of reasons why polling has become so inaccurate. Our societies have become really diverse, which makes it very difficult for pollsters to get a really nice representative sample of the population for their polls. People are really reluctant to answer their phones to pollsters, and also, shockingly enough, people might lie. But you wouldn't necessarily know that to look at the media. For one thing, the probability of a Hillary Clinton win was communicated with decimal places. We don't use decimal places to describe the temperature. How on earth can predicting the behaviour of 230 million voters in this country be that precise? And then there were those sleek charts. See, a lot of data visualizations will overstate certainty, and it works. These charts can numb our brains to criticism. When you hear a statistic, you might feel skeptical. As soon as it's buried in a chart, it feels like some kind of objective science, and it's not. So I was trying to find ways to better communicate this to people, to show people the uncertainty in our numbers. And what I did was I started taking real data sets and turning them into hand-drawn visualizations so that people can see how imprecise the data is. So people can see that a human did this, that a human found the data and visualized it. So, for example, instead of finding out the probability of getting the flu in any given month, you can see the rough distribution of flu season. This is a bad chart to show in February. But it's also more responsible data visualization, because if you were to show the exact probabilities, maybe that would encourage people to get their flu jabs at the wrong time. Now, the point of these shaky lines is so that people remember these imprecisions, but also that they don't necessarily walk away with a specific number, but they can remember important facts. Facts like injustice and inequality leave a huge mark on our lives. Facts like Black Americans and Native Americans have shorter life expectancies than those of other races, and that isn't changing anytime soon. Facts like prisoners in the US can be kept in solitary confinement cells that are smaller than the size of an average parking space. Now, the point of these visualizations is also to remind people of some really important statistical concepts like averages. So let's say you hear a claim like the average swimming pool in the US contains 6.23 fecal accidents. Now, that doesn't mean that every single swimming pool in the country contains exactly 6.23 turds. So in order to show that, I went back to the original data, which comes from the CDC, who surveyed 47 swimming facilities, and I just spent one evening redistributing poop, so you can kind of see how misleading averages can be. Okay, so the second question that you guys should be asking yourselves to spot bad numbers is, can I see myself in the data? Now, this question is also about averages in a way, because part of the reason why people are so frustrated with these national statistics is they don't really tell the story of who's winning and who's losing from national policy. It's easy to understand why people are frustrated with these global averages when they don't match up with their personal experiences. So I really wanted to show people the way that data relates to their everyday lives. So I started this advice column called Dear Mona, where people would write to me with questions and concerns, and I would try to answer them with data. People really ask me anything, questions like, is it normal to sleep in a separate bed to my wife? Do people regret their tattoos? What does it mean to die of natural causes? And all of these questions are great because they really make you think about ways to find and communicate these numbers. If someone asks you how much P is a lot of P, which is a question that I got asked, you really want to make sure that the visualization makes sense to as many people as possible. Now, these numbers aren't unavailable. Sometimes they're just buried in the appendix of an academic study. And they're certainly not inscrutable. If you really wanted to test these numbers on urination volume, you could grab a bottle and try it out for yourself. The point of this isn't necessarily that every single data set has to relate specifically to you. I'm interested in how many women were issued fines in France for wearing the face veil or the niqab, even if I don't live in France or wear the face veil. See, the point of asking where you fit in is to get as much context as possible. It's about zooming out from one data point, like the unemployment rate is 5%, and seeing how it changes over time. Or seeing how it changes by educational status. This is why your parents always wanted you to go to college. Or seeing how it varies by gender. Nowadays, male unemployment rate is higher than the female unemployment rate. Up until the early 80s, it was the other way around. See, this is the story of one of the biggest changes that's happened in American society, and it's all there in that chart once you look beyond the averages. The axes are everything. Once you change the scale, you can change the story. Okay, so the third and final question that I want you guys to think about when you're looking at statistics is, how was the data collected? So far, I've only talked about the way that data is communicated, but the way it's collected matters just as much. And I know this is tough because methodologies can be opaque and actually kind of boring, but there are still some simple steps you can take to check this. So I'll use one last example here. One poll found that 41% of Muslims in this country support jihad, which is obviously pretty scary, and it was reported everywhere in 2015. Now, when I want to check a number like that, I'll start off by finding the original questionnaire. And it turns out that journalists who reported on that statistic ignored a question lower down on the survey that asked respondents how they defined jihad. And most of them defined it as, quote, Muslims' personal, peaceful struggle to be more religious. Only 16% defined it as violent holy war against unbelievers. Now, this is the really important point. Based on those numbers, it's totally possible that no one in the survey who defined it as violent holy war also said they support it. Those two groups might not overlap at all. It's also worth asking how the survey was carried out. This was something called an opt-in poll, which means that anyone could have found it on the internet and completed it. There's no way of knowing if those people really even identified as Muslim. And finally, there were 600 respondents in that poll. There are roughly 3 million Muslims in this country, according to Pew Research Centre. That means the poll spoke to roughly 1 in every 5,000 Muslims in this country. Now, this is one of the reasons why government statistics are often better than private statistics. A poll might speak to a couple hundred people, maybe 1,000, or if you're L'Oreal trying to sell your skincare products in 2005, then you spoke to 48 women to claim that they work. See, private companies don't have a huge interest in getting the numbers right. They just need the right numbers. Government statisticians aren't like that. In theory, at least, they're totally impartial, not least because most of them do their jobs regardless of who's in power. They're civil servants. And to do their jobs properly, they don't just speak to a couple hundred people. Those unemployment numbers that I keep on referencing come from the Bureau of Labour Statistics. And to make their estimates, they speak to over 140,000 businesses in this country. Now, I get it, it's frustrating. If you want to test a statistic that comes from a private company, you can just buy the face cream for you and a bunch of friends, test it out, and if it doesn't work, you can say their numbers were wrong. But how do you question government statistics? Well, you just keep on checking everything. Find out how they collected the numbers. Find out if you're seeing everything on the chart that you need to see. But don't give up on the numbers altogether, because if you do, we'll be making public policy decisions in the dark, using nothing but private interests to guide us. Thank you.